Hello and welcome back to the development of the Feersum scheme compiler. In the last stream we were looking at fixing some bugs that I'd accidentally introduced in the way that we resolved bindings and things. So it wasn't an actual development stream where we were actually implementing anything new, but hopefully today we will be able to get a new feature added to the language, which should be lexical bindings. But let's start by going over what we did last time. So the bug that we had last time was, I can't remember actually. Let's check. Oh yes, it was in the compiler. So the problem was that when we were emitting our closure objects, we were attaching them one level in the wrong direction and accidentally sharing information between different bindings. So if you called a function more than once, you'd be able to accidentally share state between the two. I've got a spec example for that. So this was an example of code that was not working before. So if you called the make counter function more than once, the first time it initialized the closure environment, it would store 10 in it, and then the second call to make counter would still use the same environment object and it would store 100 in there. So you'd effectively be accidentally sharing state between the closures. But we solved that by changing the way that closures are lowered in the compiler so that we create instance methods if the parent lambda expression has a closure and the closure state is stored in a temporary variable. So the plan for today is to try and implement lexical binding. So at the moment we can do things like this where we define, and that's all great, and we can introduce variables into the scope using lambdas as well. So if we create a lambda expression, let's go and have a look at the itifact one because that one's a little bit more in depth. So for example, inside the body of this second lambda expression, we have the n and accumulator in scope. And in theory, if I wanted to, I could do a define here, like define phys 100, and then I would be able to reference that inside the body. So we have some level of lexical scoping, but the thing that we don't yet support is the let special form. So the let special form is a way of introducing a set of bindings for just the body, and it's basically like the squiggly brackets in C or something. So a let special form looks a little bit like this on the right. It's a let, and then it's a list of pairs, which are the bindings, and then a body expression. So where I'm going to start today with this is actually over in the binder. So in the binder at the moment, we have our storage ref, which is basically the place that a given value has been bound to. So we can bind it to built-ins or locals or globals, arguments, and then things that have been captured from an outer environment or things that are currently in our closure environment. So things get moved into our environment when they are captured. We have our binder, which is represented by this bind context, and it has a scope dictionary. So we have a new binder for each new lambda expression, and that's how we implement our current scoping. But what I want to do first is refactor how the scope works a little bit, so that we've got a way of effectively pushing and popping scopes from a stack of scopes. So instead of having a dictionary, we want something that behaves like a stack, something which we can basically say go into a new scope, and any variable decorations that are added will then be removed when we pop. So we could do that as a stack of dictionaries or a list of dictionaries, but that's going to be a pain to actually search through. And for the kinds of environments that we tend to deal with in programs, we don't necessarily need a dictionary, because a dictionary is great if you want to have like good lookups. It's a hash table effectively, or a map or something like that. They're great if you're wanting to if you've got lots of different things you're wanting to look up, and you're wanting to share the cost of lookup so that the lookup cost is roughly the same all the time. But if you look at programming languages, most of the time, like here is a reasonably complex bit of code, and we've got 1-2 parameters, and we've got a handful of locals. It's probably going to be like 1, 2, 3, 4, 5, 6. Yeah, it's going to be like 10. So what I'm going to do is I'm going to change the scope to be a list instead, and we can just search through that with a linear search. But what I'm going to do first is introduce a new module, and then we can have an isolated implementation of this. So I'm going to go over and create a new file for this, which we'll call scope. Oh dear, that's not worked at all. We'll do it with the iron-eyed window then. And I'm just going to go in and edit the CS project because I've got a long way to move it. Right, so in our binder we will open that scope first, I guess. And I'm going to define in this scope module, I'm going to define some kind of scope type. So where we're using it here, we can make this a scope. And then we'll have broken a whole bunch of places, hopefully. So I can do scope from map, I guess. And we can have scope empty which will just create as a new blank scope. What else is broken? Parent lookup. Basically all of the places that are actually interacting with the scope. And then anywhere which is got a knock-on error because it doesn't know what the type is. Or it doesn't know what things can be returned from scope lookups. So let's go implement the scope first, I guess. So what do we want a scope to look like? So a scope is going to have two things. It's going to have it's going to have a list of entries, which is going to be whatever we decide to store in the scope, and we're going to have level, which is going to be an integer. So we're going to have like the list of things that we store in the scope and the current scope depth, which I guess is binder. Wonderful. So yeah, this scope needs to be a scope of storage ref, I think. Let's implement scope empty and scope from map first. So an empty scope is going to have no entries, and current depth is going to be 0. That's that done. Scope from map, we are going to you can just start by doing returning the empty scope for the time being. Ah, yeah, true. Then we need to deal with looking things up. So we can have scope.find which you give it a scope and an ID, and it will give you either back some value how are we going to handle the case where we want to update the thing in the scope? Or it'll give you none back, in which case we do a parent lookup. Or we're doing a try find binding. Where we're doing the same thing, I think. It's going to be scope dot find in the current scope, and if we get some value, we'll return so what we'll have here is effectively when you do a lookup in the scope, it'll return an option with the entry in it, and then you'll be able to read and write from that entry if you want to. Should that really? We use a different API for that. And then this could be optimized into an option, one of the option methods in a minute. This here has to be scope.insert again in that scope, that ID, that storage. Good, so we need to write scope.entry, scope.find, and scope.insert. So we have a scope and an ID. We've got an entry API as well, which is going to do the same thing. Actually, let's do those the other way around. Because if we do find second, we can always make find just call the entry API. This allows the value stored in the scope to be needed, which it is sometimes. Find and insert, which takes a scope, an ID, and a value to store as well. So, adding a value to the scope, we're going to want a scope entry type, which is going to be, it's going to have a mutable value, which is of type T. It's going to have a depth, which is int, and it's going to have an ID, which is a string. And this can be a scope entry. So what we would do there is we would say scope dot entries we could make this API not mutate any of the things and always return a new scope. Or we could just allow the entries to be mutable. In the binder, the scope is already mutable. No, it's not mutable. Might be nicer. Might be nicer to keep the mutation inside the scope. Inside the binder context. So let's do that for the time being. I'll make scope mutable. So then here, what we would do is we return a new scope that has, we create a new entry. The entry is going to have a value, which is the value. It's going to have an ID, which is the ID, and it's going to have a depth, which is the scope dot current depth. Then inside here we say entry we prepend the entry onto the list, and we set the, we can just do this as a with expression. That's looking reasonable. Returns a new scope with the good. So now the binder should at least type check, which it does. And the only place we're mutating the scope is when we're adding bindings, which happens there. Add argument binding does scope.insert, and we want this to be an assignment. So those are the two mutations of the scope. Right. So then find is a case of the entry API is going to be the simplest one, I guess. It's going to list match list.find. Find the scope entry where the ID is the same as the ID we've been given in our scope entries. If we found it, well, that's it. We can just return it. Don't need to do anything fancy. And there's too many equals there. So you give it a scope and a string, and it returns you a scope entry option. Try find. So find is going to be option dot is going to be entry scope ID option dot map. It's just going to pick the value out of the map. And can we rewrite that as find equals entry no. And then to initialize a scope from a map, we'll say create a new scope, and then we'll say list.fold. No, map. So map.fold will basically fold over the collection. We need something that takes a state, a key, and a value, and returns the new state, the initial state, and yeah. So this can be empty. So we'll use the empty to create a new scope. We'll use then we'll use map.fold, which is going to take state, key, and a value, and it does scope dot insert. Need to reorder this a bit. And what's going on there? We just need to do insert. That needs the scope. And yeah. Good. So now, if everything's gone well, I should be able to rerun. Oh dear, it's not compiling somewhere or other. Scope from map does not match the type map of string to something. Do scope from that. Scope from map. Type scope of storage ref does not match the type. What's going on there? Is that even a real error anymore? It looks like it. Write it without the pipeline. So that's saying we haven't given it the map. We can do that, I think. No. map.fold doesn't take things in the order that I was expecting. So it takes the initial state, which is going to be an empty scope, and then it takes the map to fold over. So right now the type signature is map of string to scope. So hopefully this should be happier. So I can go back to using the pipe for that. Because it's not functional programming if you're not piping. Right, that looks like it is compiling. Let's run the tests. So if everything has gone well over this initial refactor, this should work exactly the same way that the previous one did. And it does. And this supports the same kind of aliasing that we previously supported. So what we can do now is when we pass the, well, let's commit what we've got. So we've got changes to the compiler. What changes to the compiler? Oh no, it's open editors, not. So we've got the new scope instead of the dictionary. That all looks good. We've got a bunch. I don't understand. Revert the change, please. We've got our new scope in our project file. And we've got the new module. And do you think there's anything that you need to do now? Nope. Switch to list for scope implementation. Scopes. So now we've got scopes. We could add some unit tests for the scopes, but I'll not bore any of you with that. So the actual thing that we want to accomplish is pushing and popping scopes. So in the binder, we recognize a whole bunch of special forms like lambdas and stuff like that. So we'll start by just implementing the let body. So a let body is well, it's the keyword let, then some bindings, and then a body. So we'll do it like we've already matched the keyword let. So we could just do match body with, and then body has to be a list with two things in it, formals or bindings and body. And if that is the case, we'll do some stuff. Otherwise, we will raise an ill-formed error. which is now as simple as doing ill-formed let. And we can get rid of our not implemented. So pattern matches for this expression, yeah, but it's not really incomplete, is it? So I think what we want to do here is say let bindings equal bind So we need to find a way of initializing all of the bindings. So the way that define does it is if it's given a value, it does binding context and then adds a binding for that. And then emits a bound expression store. So this is effectively what we're going to do for everything in our bindings. Bind lambda entry so that's going to take a value, an ID, keep them around. So what we're going to do is we're going to have to do something to the bind each of the definition. Then we're going to bind the body of the lambda. But what we need to do first is, so we're going to bind each one of the definitions, then push the increment the scope depth, and then decrement the scope depth. So anything that's bound inside here will be removed from the removed from our bindings. This is going to be useful because we treat the scope as an immutable piece of data. When we increment the scope depth, we're going to be able to keep track of the new scope and the old scope, which is useful for all the different types of let bindings that Scheme supports. Because in some let bindings, and I can't remember which around these are actually, you've got like let star and let rec. In some of them, the values are bound in the outer scope, and some of them they're mutually recursive. So let's say let scope equals binder context dot push scope. So push scope's going to take the context, add a new level of scope, and I'm going to have a binder context pop scope or restore scope. So that's going to be in binder context, we're going to want two ways to manipulate the scope. Push scope context. So if you're pushing a scope, we will do context.scope context.scope equals scope dot push scope, and we'll return the old scope, and pop scope or restore scope is going to say scope, you give it the scope to restore it to, and it just writes it back. Set the scope back to restored value. Do we even need to know what depth we are at in the scope here? I'm not sure we do, to be honest. We could just say context of push scope could just do this, could just return the scope for the time being. So let bound body equals bind form context body. What do we... Oh, this resource scope needs a context. So this at the moment would be returning whatever the bound body is, but bind bind form, is there just called binding context? Yeah. So that's our increment the scope depth. We need to deal with handling all of those variable initializations. So what we're going to do is What is bindings? It's an AST node, so we need to match it somehow. Bound decals bind let in the current context bindings. So we'll do something to bind those declarations. And we need to do that by so a bind decals is going to take, well, I mean, if we do it as a local function here, we don't need to take the context or the scope. We can do bindings with if it is a form I must ignore the value somewhere. Do I need to? AST node dot. Oh, it's AST node kind. So bind let decals. And we'll do list.map bind let decal over the decals. So we'll end up with a list of something. Well, that's going to be AST nodes, isn't it? Token is offset. Well, we don't actually need to we can just emit a diagnostic for that. So we'll say bindings is a node. So if we get bindings, we've got these bound decals, we're going to need to do something with them. It's going to be, it's a list of a unit at the moment. I think what we want is a bound. I think we want this to become a sequence expression of list append sequence so a bound so wait, append takes what? A list? Takes two lists. Let's do that then. So we end up with a sequence. So we need to turn each declaration into an initialization of the variable, basically. Which means more matching. So the case we're looking for is expecting these to be another form. So we've got a binding. It's just going to be, it's not a list. If it is not, we can emit a diagnostic. And return an error. Okay, let's try this out. We should be able to get some diagnostics. I mean, we're not going to be able to correctly do any bindings, but we should be able to write some let expressions. So if I do let and give it a form, what does it evaluate to? We've got some diagnostics. Oh, the diagnostics are empty. So it's going to emit. I can probably get rid of all of these breakpoints. So we get 123. So that's good. If I give it something like this, a 123, it's not going to work. Reference to undefined symbol, but we don't get a diagnostic because this is correctly formed. But if I do something like that isn't, it says invalid declaration and a reference under a defined symbol. Good. So we need to get to the point where we can define a value. So we'll do a match on the binding again. So this is the form with which should have an ID followed by an expression. So we expect the binding to be a list containing something which has a kind ident and something, just a body, but it has to be just a single thing. And we can do invalid binding form, I guess, here. So what's going on here? I think I'd got some funky white space. Good. So if we've got an ident and a body, what we want to do is bind the body in the initial scope. Bind in context, our current context, the body, and we'll return the bound at the end, and then we want to add it to our scope. But we don't, let's say, which way do the different lets work? Each init expression. Let's have a look at the spec. Each init expression embodies a sequence of 0 or more definitions followed by a sequence of 1 or more expressions as described in section blah. Each init expression embodies a sequence. Okay. Oh. Yeah, okay. So it's saying that you can have as many bindings as you want, and then body can actually be a sequence. So you're allowed to have more than one statement in a lambda. I don't know if we support that yet. And then the inits are evaluated in the current environment in some unspecified order, and then the variables are bound to fresh locations holding the results. So we need to bind them all in the parent environment and then set the scope. So what we will do is for everything in this, we will mutate take a copy of the scope and then we'll create this new scope copy and we will bind them all in the original context because you've not done anything to the scope yet, and then we'll do new scope is scope dot insert new scope ID we've got the storage, I think, which we need to give the ID. Is that going to work? Oh no, value. So we build up this new scope, and then before the body we say context dot scope is new scope. Right, let's try that out. That's gone wrong there. Right, best to just bin it. Bin all the terminals and try again. Come on. It still thinks the debug is running. let with no bindings still works. Let a 100, so bindings, then just a is null. Why? It's not an error. We just do a bound. So this needs to be a location. So we create a new location, storage location, and then we return a bound expression dot store, which takes a location and a value. No, yes, yes, no. What's the problem here? It's expected to have, needs to be some bound. What are you upset about? And we want to insert the location that we just made. So the problem we were having before was that we were calculating the initializers for all of the locals, but not actually using them for anything. So when it tried to read from the local, it was broken. Debugger keeps on getting out of sync with the terminal. Let a 100 a 100. Let's try and do one of the examples. So x to y3, and then nope, that did not work because I didn't copy properly. Because it's Emacs. Does this equal 6? That should be a lowercase x. It does. Wonderful. Let's try something a little bit simpler. More complex. 70. What's gone wrong there? $70 is 2 times 35. Have I copied the wrong value? So we've got, this is the example from the scheme again. So we've got a declaration for x and y. Then we've got a declaration of x again as 7. So then z should be, so x should be 7. So we're going to do something times 7. Then z should be x, which is 2 because it's this one, and y, which is 3, so it should be 5. So it should be 7 times 5, which should be 35. But that's clearly not what's happening. Is doing 10 here because it's doing x as 7. It is, yeah, the wrong x is being used. Just need to work out why. So we always bind the bodies with the initial scope, hopefully. Because we should do this list map here, which binds all the declarations, which happens before we copy the new scope across. So I guess we just need to have a look at what our scope is inside this block. Let's just do the same thing again. So we've got our saved scope, got a new scope. Our bindings is a list. So what is saved scope? Has 10 entries in it. Because it's all of their built-ins and things. Yeah, and nothing useful. So when we bind all of the initializers, we should basically get 2 initializers here. One for 3, one for 2, one for 3. The other option here is that it's looking the values up from... No, that wouldn't make any sense because it shouldn't even be in the scope. Yeah. I was going to say it could be looking it up from the wrong end of the list of values, but new scope now has 11 things, now has 12 things. So it's the original things with our X and Y in there. Great. So now we store that on our context and then bind the body, which is going to contain our second let, which contains... So we save the scope so the save scope is our scope with 12 bindings in. Bindings is a list. So we map it and we get one initializer, which is 7. What is so we're going to store so the scope stuff's all working correctly, but we're working with global variables. Yeah, that's really awkward. I'll have to have a think about how to solve that. But for the time being, I can make this work by defining an anonymous lambda and calling it. So that should hopefully problem isn't that where we're not looking up the wrong location here, but both locations refer to the same piece of storage because it's a global, it's just a property. But if we have a lambda, the storage location will be different. Do need to handle the case of using a let globally though. We could make a temporary for it, maybe? But then it's not going to get captured properly. We just need a way in our context to make something that's ephemeral, effectively. Join those lines together. Do that. Call it. Let's just F5 through the whole thing, hope for the best. 35. So the scope stuff is working, but let expressions don't work with global variables. I'm happy to leave it there though. And I'll have a go at implementing the other forms of let expressions and coming up with a solution to the problem of how we deal with globals. Let's get rid of these comments because they're not really right. They don't really in the new scoop. There's a couple of tidy up things that need doing. So in the scope itself, we don't actually need this current depth. The plan with that current depth was to be able to know how far we needed to walk back up the scope stack, but because this is all immutable, we don't need to. We can just take a copy of where we wanted it to be and restore it. Right, so that's it. Thanks for watching. I hope you've found it at least mildly enjoyable. I will be back at some point in the future, and I think the next thing I want to try and work on after I've got lexical bindings all working is macros, which should be interesting. Going to be a whole load of pattern matching and that kind of thing to build up macro definitions, and then we'll have to have a way of storing the macros somewhere in the compiler, matching them against the source text, so that's going to get quite abstract, and then expand it out into whatever the form needs to be. But yeah, thanks for watching, and I'll see you next time.